Okay. It is now live.
Awesome.
So, oh, I guess we'll get started with the prayer.
Oh, okay.
I don't know who said it last time. Say it.
I can say it if you want me to.
Okay.
Our dear Heavenly Father, we thank Thee for this opportunity that we have to gather together to talk about trig identities, and we are grateful for the opportunity to increase in our educations. And we ask Thee to bless us with Thy Spirit, that as we do this, we may be able to learn effectively and move quickly through the prep and extension problems and also the quiz, that we may be able to also understand what we are learning. And we ask these things in the name of Jesus Christ. Amen.
Amen. Awesome.
Okay. It says, talk about the preparation.
So with the preparation, like 50 tabs open, can't find what I want.
Yeah.
Probably I'm fine with the identities, fine with the substitution and whatnot. It's when it gets to like the double angle and half angles. I don't know why I keep tripping up on those problems. But I haven't gotten time to go through the book like I normally do with them. But I think I'm just behind this week with those.
Yeah, this week was a little weird for me too. Yeah, like sometimes I understand like what's going on with those two specifically as well, but like other times I like trip up or whatever. Like what you said.
So just started up talking about things.
Awesome.
Identity. Yeah, and like all the identity stuff, like writing it for you can write the different one. I'm good with those, but sometimes whenever it's like use a triangle to help, I guess I'm not 100% sure how to find the quadrant based on what it gives us, because I feel like it'd be somewhere different than it is in like the answer key, and I don't even know where to begin to fix that.
Mm.
But like I said, I usually sit down and go through the textbook, but I haven't got a chance to really sit down. This week's been a little hectic.
Yeah.
I mean, if you want, we could go through some of the. Am I on the right page? Yeah. We could go through some of either the extension problems or some of the prep ones to just maybe try and see if we're even on the same page with some of these. Because yeah, I either feel like it's really clear, it's easy, or I have no clue what it's asking. There's no in between.
We could do like the extension problems.
Okay, that sounds good. Another application of the identities is to be able to use them to solve for a specific value. Begin by going through the following problem that has been outlined for you, then maybe asked to do a similar problem. Okay, so it walks you through it, and then it wants you to do a different one. Maybe that'll help. Okay. So, okay. So it's find cosine of a over 2 given sine of alpha equals 3 over 5.
Okay.
Angular. So it's like, what's the question asking you to find angular side length? And so it would be
Side length.
side length. And that's because cosine is adjacent over hypotenuse. Is that where that's coming from?
I just said side length because the sine was in side length. Well, and because it's not a negative, it's not a inverse identity or whatever.
Oh, okay. See that. Write the identity for cosine.
Of the cosine half angle.
Oh, cosine, the half angle because it's over 2. So it'll be plus or minus 1 plus cosine x over 2. Okay. In order to find cosine a over 2, what do we need? Well, I guess we can't solve it. We don't know the variable in it.
One sec.
Yeah, because if that's the identity, I mean, we'd still have to solve for cosine. See, will drawing a triangle help you find the missing piece?
Yeah, I think so, because we have sine. And so essentially we just need to find one more side of the triangle. We can do that by using the Pythagorean there.
Oh, true.
Oh yeah, we can do that.
Okay. So how do we know from here, like, where we draw the triangle and what quadrant it's even in? Because I see how it gives the a is greater than pi over 2 and less than pi.
Mm-hmm.
So less than pi. Okay, so pi is like the top half of the circle, right? I'm trying to think of it in my head. Pi, because pi is one side. Pi over 2 is that 90 degrees? Pi, half a pi. I think so. Yeah, so that would be in pi. Yeah, so that'd be in quadrant 2.
I think so, yeah.
Wait, greater than pi over 2.
Because no,
Wait,
so it's less than, oh yeah, it is greater than pi over 2, but it's less than pi. So it's between 90 and 180. So it is in quadrant 2.
okay, yeah, pi's on the other side.
Yeah, pi is 180.
Cosine over 2. The sine is 3 over 5. So sine's opposite hypotenuse. So then the missing side would be 4. Okay, so cosine over
So cosine then would be negative 4 over 5.
why is it negative 4?
Because it's in quadrant 2.
Oh, okay.
Yeah.
Would the 5 be negative for
No,
the on the hypotenuse?
I don't know if the hypotenuse is ever negative. Is it?
I don't know, because I mean it's going toward the negative. I don't know, because I see 3. I mean 3 is going up, 3 is positive, 4 is going to the left, so it's negative. But well, I guess it's not negative in the sign. Sign the 3 over 5. So
Yeah, so it wouldn't be.
yeah, I'm just gonna assume it's not because of that.
And then by substitution, you should now be able to find cosine half angle or half angle.
So that'd be cosine negative 2. Wait a minute.
Oh.
Because wouldn't A be -4 back into the cosine of A over 2? Is that what it's asking us to plug back in?
By substitution, you should now be able to find cosine. You should have found that cosine.
Over 2. Yeah, see, I don't get that. You should have found that cosine of A over 2 is 1 over square root of 10. Like,
Yeah.
where did that come from? Yeah, so it says because A over 2 is less than pi over 2, but greater than pi over 4. 2 pi over 4. Like, I don't even see where that value's coming from. Does it calculate to be the same thing? No. All right, cosine of, yeah. Okay, plus, well, I guess if we go back to the identity where it's cosine A over 2 equals plus or minus the square root of 1 plus cosine, if we go through all that and plug in cosine of A, wait. Okay, so we still need cosine of alpha.
The sine of A. Which is 3 over 5.
Okay.
And
Okay, so we plug it back into the identity, and that gives us the 1 over square root of 10, and it's positive because to fit into the parameters.
Oh, I see, I see.
Okay,
let me try that. Here we go. Cosine of that, which is just 5, 2 minus oh. Wait, so you plug it back into the half angle identity?
Yeah, so you plug so in order to find the cosine alpha, it would be -4. It would be the cosine of -4 over 5 because that's the, so adjacent over hypotenuse. And then if you go back to the identity, the square root of 1 plus the cosine of -4/5 divided by 2 equals 1 over the square root of 10. It checks out in the calculator as the same value, but I didn't work it out by hand because I'm still trying to figure out how to do it and not mess it up.
Gotcha.
But I was just trying to verify it to see if that was the same thought process. But yeah, it would give you a plus or minus value, but that would that equates to the 1 over square root of 10, and it has to be positive because the negative value doesn't fit within the parameters.
Oh, gotcha. Okay.
I'm trying to see if it's cosine of -4/5. Like, how does that mathematically equal out to it? Oh, wait, hold on. I think I'm onto something. Let's cosine 2. No, never mind. Yeah, I don't know how to work out the cosine of -4/5. I don't know how that works out. I imagine somewhere the 5 multiplies by the 2, you get the 10. Can't take the square root, but I guess I'm not seeing how it plugs into what the answer is.
Mm-hmm.
Yeah, like I can check it in the calculator and it all checks out. It makes sense, but I don't know how to write that out. Hmm.
Okay. Yeah, that last little bit is a little bit confusing to me, but
Yeah, see, it's good up until that point, but
okay, should we try like a different problem or
here, let's go through one more problem. Let's see if we can maybe figure it out. Because I know it's already like 30 minutes in, but let's try to figure out another one, see if we can kind of maybe figure it out a different way, and then move on to the group quiz.
okay. Which one should we do? The rest of these are just like identities and rewriting them and simplifying them, I think.
Yeah. Do you want to do number 3? It's pretty much the same thing we just did, but maybe we can
Yeah, we can do
figure it
that.
out.
Okay, yeah, we can do that one. Okay, so what we need to do first is solve for sine of A of alpha, right? Oh, no. I meant sine of beta.
Okay.
And we'll do that. I know it worked. There were some of these problems on the homework. Here it is.
Okay, sine. Number 5.
It's in quadrant 4. And the sine.
So the identity for that one is the sine alpha cosine beta. Alpha sine.
So you have sine, 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 cosine, cosine.
Oh, okay. So that would be
Now we need cosine. Okay, let me check that with the answer.
I'm off.
So I was able to find the answer to that one. Where are you stuck at? Or like,
See, for your triangles, did you get the 4, 5, -3 triangle?
oh, I didn't use triangles for this problem. I guess I
Oh,
could have, but I didn't.
I used triangles and then got all mixed up on my values.
Okay.
How'd you do it?
Um, me. Let me see if this makes sense. So we have the sine of alpha and plus beta, blah, blah, blah. This is like the problem part. And so, and
Okay.
it's in quadrant 4. And so here I took the Pythagorean whatever identity, sine squared of x plus cosine squared of x equals 1. And so I use that to solve for, what did I do first? I solved for sine of beta. So I put sine squared beta plus cosine squared beta equals 1. And then I just rearranged them algebraically and got sine of beta equals the square root of 1 minus cosine squared of beta. And then plugged in the cosine squared of beta because it gives us that here in the original problem. And so I found out that sine of beta is 2 times the square root of 2 over 3. And then I basically did the same thing and just solved for alpha, or I solved for cosine of alpha. So I just rearranged them, plugged sine of alpha in because it also gives us that right here.
Okay, that would have probably been the better identities to use.
And then I got this. And then I finally solved. What did I do next? Because
Oh yeah, then you did, yeah, the sine alpha cosine beta. That's what I did. I found the triangles and then I started those, but yeah, I got the square root of 8 and I think that was what was throwing me off.
okay.
Because it calculated out and I got over 15, but I got square root of 8 and well, I guess that could go out to the 2 if I'm looking at the answer key. What does 8 come out? 4 times 2, square root of 4. Oh yeah, well, square root of 4 is 2, so then that would give me 2 square roots of 2. And then 2 times 4. Yeah. Oh, okay. Wait, no. Yeah, so I just didn't simplify it out more. Because 2 square roots of 2 times 4 is going to be 8 square roots of 2. 3 minus 8 square roots of 2. Yes, over 15. Okay. So, okay, I had the right thing. I did it by finding the triangles. I plotted them out and I drew the quadrants and I found all of the sides of the triangles and then just plugged those into the sine of alpha cosine beta and found all those values and worked them out. But I didn't simplify it far enough. That's my problem.
I mean,
Never
that's
mind.
math. If you're doing everything correctly, then you'll end up with the same answer.
Well, and I guess that's kind of what it's trying to get us at is a lot of this is saying, find different methods, which that's what we're doing. I mean, we do it different ways, but it's still coming out to the same problem. So
Yeah, that was kind of cool.
cool. I don't feel so bad anymore.
Okay, you want to start on the quiz?
Sure.
Okay.
Pop it up.
Bring it up here. That's the quiz.
I know I've got the quiz, the hangouts, the resources, okay.
Okay. For the first problem, simplify the following trigonometric expressions.
Okay. Do I have to simplify it in terms of anything, or just? Well, I guess this one will be
It just
easy.
says simplify it.
Yeah, because I think some of these should cancel out, but I'm gonna go slow to make sure.
I think that's if we were multiplying it. Maybe. I'm not sure.
I need to print out this identity sheet and like memorize it.
Yeah, I printed it out. I haven't memorized it.
Okay, let's So we start by multiplying them to get the least common denominator.
That's kind of what I was doing at. I'm not sure if I did that one right, but here's what I got.
Yeah, give me 1 second.
Okay.
Almost. What did you get?
Oh.
I don't know if you would cancel out and be a half.
This is top one. This is what I got in the end.
Yeah, that's not what I got.
What did you get?
1 minus cosine x over 2 minus cosine x. But I think I canceled out some of these that I don't think I should have.
Okay.
Hold on. 1 minus cosine x times sine squared. Okay, so whenever you multiply them, what did you get when you had it all multiplied out? Or I guess a better one, did you multiply both sides by 1 minus cosine x times sine x? Is that what you would have multiplied them by, or no?
I'm not sure what you're asking, but this is what I did.
Let me see, sine x. Yeah, see, this one was 1 over cosine. Okay, 1 minus cosine. Sine x. So did you just multiply each side by the other value?
Yeah, to get the common denominator.
Yeah, so like the first one, the sine x, 1 over cosine x, did you just multiply that whole thing by sine of x? And then
so I multiplied
sorry.
this by, so I went this times this times this, and then I did this times this, and this times this, and that gives, so this times this is cosine squared of x. This times this is that, sine of x minus cosine x sine x. And then this times this is this whole thing, 1 minus 2 cosine x plus cosine squared x. And then the numerator, or the denominator, is the same, because this times this is the same as this times this. And so I just added those together. And then I regrouped them over here to where I have sine squared x plus cosine squared x. I like isolated those off. And then I have plus 1 minus 2 cosine x. And this is equal to 1, and so I just substituted that down here. So 1 plus 1, and then minus 2 cosine x. And then so that got me 2 minus 2 cosine x over that.
Okay, I see what you did. So you started off with cross multiplying.
Yeah.
Okay. See, yeah, I started off. I didn't know because I thought. Well, I guess no, they're added together, so you can cross multiply. I did it with originally 1 minus. Like I took both of the denominators and multiplied them. So I multiplied the whole thing by 1 minus cosine of x times sine of x, and that gave me this ridiculous thing that just fell to pieces as it got further and ultimately divided, I guess, to 1/2. But I'm not even sure if it's supposed to. Because I got some stuff to cancel out, but I think all I did was just I timesed it by itself and then divided it by itself. And then eventually all here, they all just reduced down to that. Because I think that's pretty much all I did was just times and divide by the same thing.
Okay.
So, well, I failed that one.
Well, I am not sure if mine was 100% right, but
Yeah, I just
it kind
because
of,
when they're added together, because you can cross multiply when they're added together. I guess just for my knowledge, like let's say you had you can't. I know this isn't a true statement. You can't cross multiply that, right? Like because that's a whole different issue.
yeah, no, I don't think you can. You would,
Oh,
yeah.
okay. Yeah. Well, that makes sense. Um, if you want, I can try to work it that way real quick and see if I come up with the same answer.
Okay. And I can start working on a different problem.
Okay. X. Point.
Yeah, the next two problems are like way, way simple. A lot simpler than that first one.
Oh, well, that's good to know, man. I'm trying to figure out this just to make sure I'm
Yeah, okay.
doing it.
Yeah, yeah, yeah.
Like I said, I'm never doing this online again. Oh my gosh. Yes, that would be. Yes, that would. Sine squared x minus 2. Sorry, to go back to the first one, where you multiplied the 1 minus cosine x to the 1 plus cosine of x. Oh wait, that's a minus. Great. Well, still, whenever you multiplied it to that minus, would cosine x times cosine x be 2 cosine x or cosine squared when you multiply them together?
Could you show me, like, give me a visual?
Here. Whenever you, sorry for all my scratch marks.
No.
But so I multiplied the sine by the sine x and sine by this cosine. Well, whenever I multiply this 1 minus cosine x to this one, ignore that's a minus, 1 minus cosine, and factor that, would the cosine, whenever I multiply the cosine by the cosine, would that make it cosine squared? Is that where you got the cosine squared for the top part of the equation?
Yeah, so if you do 1 minus cosine, and then here I have just a little thing. If you do 1 minus cosine times 1 minus cosine, you end up with 1, and then you get 2 of these negative cosines, because negative or cosine times 1, and then cosine times 1. And so you just add those together, you get 1 minus 2 cosine, and then plus cosine squared, because right here.
Okay, and the 2 cosines come from the 2 negative, because you do the 1 times cosine, and that's one of them, and then the minus cosine is the other one. So that's the 2 cosine.
Yeah.
I was making sure I wasn't getting that confused with the cosine squared.
Yeah.
So then, what did you end up getting on that one again?
I got 2 minus 2 cosine x over sine x minus cosine x sine x.
Okay, I got 1 minus 2 cosine x over, I factored out the sine. I don't know if it needed to be. I factored the sine x in the denominator into sine x parentheses 1 minus cosine x, but I don't know if it even needed that.
Oh, gotcha. Where did you get the one? Just the one?
Oh, I forgot the original one that was there.
Oh yeah.
Okay. I left at that. Okay, yeah, so I'd add that one, and that would give me 2 minus 2 cosine x. And then, yeah, I did the sine 1 minus cosine in parentheses because I don't know if we needed to factor out that sign or just leave it. I don't know if she wants it way, way, way simple or.
Um, I mean, I don't think it could hurt.
Yeah. I mean, I think it's fine.
Okay. Oh,
Sorry, I'm like super slow.
okay. Um,
Okay. Said the other two were easier. I mean, I can go through those normally. I know I'm just slow. That's why I feel bad being part of a group.
no. You're all good.
Let's see.
This last one is tripping me up, though.
So that one's verifying identities.
Yeah.
Here. Let me jump to that one real quick. See if.
Okay.
Okay. Okay. Like X.
Ooh.
That's weird. Cosine is over secant. That doesn't make anything. Sine. Yeah, that one's tricky, man.
Yeah.
I'm not quite sure what to do with the I tried going to the left side, but I'm not quite sure what to do with the 1 plus cosecant, so I switched to the right, but that just got me things in terms of sine, which I don't really know how to get the sine to look back like cosecant.
Well, so sine is 1 over cosine, or cosecant. Oh, so cosecant squared? Oh, wait a minute. What did I do there? Why did I do that? Okay. I don't know what I did there. Huh. Interesting.
No, it's always when you look at it a second time.
Yeah, for sure. So then I don't need this.
I'm gonna try to go back to the left side. Well, no, then I don't even know how you get rid of that one.
Yeah, the one's kind of confusing.
Yeah, that's what's throwing me off is I'm trying to figure out where it comes from.
Did I see it? Because we have the Pythagorean identities. Oh no, that wouldn't even work because it's not squared. Never mind. Yeah, never mind. Bringing it. No, because I can't do that.
Well, if we started, well, here, I have an idea. 1 plus sine over CS. Oh, wait, hold on. I think I might be onto something.
Oh, good.
So that's 1 minus sine CX. If we, oops, wrong thing. So that's 1 minus squared x. Okay, hold on. CSCX. Squared. Because I thought if we take the right half of the group, like the right side, and we can square that side, and then that would give us cosecant squared. That would give us sine squared.
But we'd have to square everything, both sides. Because by squaring it, wouldn't that like change the value? Like change the equal?
Well, I saw in the, and I don't know if I'm going about this the right way, but in the identities, the page, at the bottom where it's like strategies for verifying, it's like work on one side of the equation, usually the complicated one, so it looks like the other side. Would that still apply if we squared one side? Would it still square the other side in the identity case? If so, then yeah, maybe I have to find another way.
Yeah, I'm pretty sure.
Okay, I see. Well, I was going somewhere with that.
Oh man. What do you have so far? Here's what I got so far. I don't even know if I'm going about it the right way, but I have so I have the written one here. I stuck in the negative things and I flipped the signs. So this flipped to positive, this flipped to negative, blah blah blah. And then what I did here is I turned this into a sign essentially and just multiplied it by 1 minus sine. And so I got this thing. I got sine of x minus sine squared of x. And then I don't know what like to.
Okay, and this one, yeah, let me pull up my computer. So I got to where you were with I did the negatives too.
Uh-huh.
And then I tried to find something else. I tried to put the sine into the cosine. I turned where is it? Sine squared into sine cosine. That was me trying to find a different way to look at it. But yeah, I got here with the negatives, and then sine squared 1 minus. Yeah, I turned the. Oh, wait a minute. Oh yeah, so since the cosecant's on the bottom, the sine wouldn't be on the bottom. The sine would be on the top multiplied by these, right?
Yeah.
Okay. Okay.
Yeah.
Okay, that I should have done right.
The rest of this though is tripping me up.
Okay. So then that would be sine x. That's where you got your sine
Yeah, yeah.
x. But then the other side, we would still have sine squared x over cosine. I mean, could we turn that cosecant into a sine and multiply it again, and then it would all just be over 1? Could that work out? Because technically then that would turn the denominator into 1 plus sine x over 1.
But then we'd have then we have sine minus sine cubed because we already have squared there. And so
Right.
it's like almost there, but like not quite.
Yeah. Unless we factored out a sine. But I don't know what good that would do necessarily either. That will give us sine x cubed x. Wait, are we verifying if they are identities?
It just says verify the identities.
Unless, because if we multiply this one out, then it would come out to sine minus sine cubed equals sine minus sine squared, because then the one would just divide under it, which that isn't an identity. So I don't know if maybe getting to that point we would say this is not an identity.
Maybe. Yeah, possibly.
I mean, I don't know if that would if that's even what they're looking for. But I know even going through those steps, we'd get credit for having the thought process.
Some of it, yeah. I mean, that makes the most sense to me right now.
Yeah, because even factoring out sine, 1 minus sine squared, is that something?
That is cosine squared.
1 minus sine squared?
Yeah, but putting it into cosines doesn't really do anything for us right now.
Yeah.
I guess we could go back over the last two questions just to like
Okay.
make sure we're on the same page.
Yeah, on this one, like, yeah, even going through it, like, even if you turn it into like factor out the sign, you'd still get like sine of cosine squared equals sine of cosine, which still doesn't
Yeah.
come out, because like you could keep subbing, but yeah, because of that squared, you can't ever get it out. So
Yeah.
I
So
don't know.
I guess we'll say it's not equal. But for
Okay.
For the first one and for B,
Now the tangent.
oh, yeah. So we got tangent here. Where is it? B. Tangent of alpha and then cosecant. So this was pretty straightforward because cosecant squared of whatever minus 1. If you look on the chart, it's a Pythagorean identity basically. But that equals cotangent.
1 plus cotangent.
Yeah, so 1 plus cotangent equals cosecant, and then just algebraically rearranging it, you'd subtract both sides by 1, and you get what's in here. You get cosecant right here. Cosecant.
Squared minus 1, right?
Minus 1. Yeah, and so that equals cotangent. Cotangent squared. I think I put that in here. Yeah, right here. And then over here, what I did is I put tangent as 1 over cotangent.
Okay, so it could divide.
And then it literally just divides into, and then you get cotangent.
Cotangent 8. Okay. Let's see, tangent squared. Tangent 1. Okay, yeah. Tangent is cotangent 1 over cotangent A, which cotangent squared. Okay, which it just comes out to cotangent of alpha, right? Or yeah. I guess of x or alpha, whichever it had. Alpha. I keep putting x's because when I look at the identities, a lot of them aren't x's, so I just get flopped. Okay, last but not least, the A on the other one. That's where x cotangent.
What? And then for number 2, this is what I got.
CS. Cotangent. So you put. Oh, so you put cotangent as cosine over sine. Sine canceled out. So then you have cosine. And then secant is 1 over, double check, 1 over cosine.
And then those two cancel out. And then you just get cosine of x minus cosine of x, which is just 0.
Ollie, really? That's kind of, well. Yeah. I mean, that makes sense to me.
Yeah, and me too, but I guess, I don't know.
Oh, yeah, it's fine. Yeah, I mean, that looks good. That's what I imagine them to be. I hope they're not, deeper thinking than that.
Yeah. I mean, they have to give us some easy problems.
Oh, I hope so.
Well,
okay, well, I mean, that looks good. I haven't even done the quiz yet, so I'm probably going to jump on that.
Individual quiz?
Yeah, but I'll get this submitted before that just to make sure it's in. Who wants to submit the group quiz? I don't know if we're still going in order, if we even have an order anymore.
I can do it. I have it all.
Okay. Like my work ends up spanning like multiple pages. So then like I have all this chicken scratch in between.
Yeah. Yeah, I can just submit it. Week.
Okay, that sounds good. Thank you.
Yeah.
Oof.
I guess, does anybody have any other questions or?
I'm good.
Okay. I guess see you all next week then. I'll just go ahead and submit this.
Awesome.